Hello everyone. Today we embark on a fascinating journey into the world of differentiation. While the term might sound complex, differentiation is a powerful tool that has revolutionized the way businesses and investors manage risk and seek opportunities. In part 1 of this lecture series, we will explore the fundamental concepts of differentiation, understand their various types, and eventually, when we get to part 2, we will delve into their practical applications in the realm of business and finance. By the end of this series, you will be equipped with a solid understanding of what differentiation is and how it works. We will demystify the intricacies of differentiation and explore its underlying principles, the different types of differentiation. We will examine various key concepts, formulas, options, and discuss their unique characteristics and uses, the role of differentiation in management. We will explore how differentiation can be employed to calculate things like marginal revenue, marginal cost, average variable cost, just to mention a few. We will look at several real-world applications of differentiation in areas such as management, finance, etc. By gaining a comprehensive understanding of differentiation, you'll be better equipped to make informed decisions in a complex and ever-evolving financial landscape. So let's dive in and unlock the power of differentiation together. So we'll start with the definition of derivative, and in this section we'll define derivative, give various notations for a derivative, and work on a few problems illustrating how to use the definition of the derivative to compute the derivative of a function. In this section, we give several of the more important interpretations of the derivative. We discuss the rate of change of a function, the velocity of a moving object, and the slope of a tangent line to a graph of a function. Next, we look at most of the general derivative formulas and properties used when taking the derivative of a function. Examples in this section concentrate mostly on polynomials, roots, and more generally variables raised to powers. In this section, we'll discuss one of the more useful and important differentiation formulas, the chain rule. With the chain rule in hand, we can differentiate a much wider variety of functions. As you will see throughout the rest of your courses, many of the derivatives you solve will involve the chain rule. In this session, we will give two of the more important formulas for differentiating functions. We will discuss the product rule and the quotient rule, allowing us to differentiate functions that up to this point we were unable to differentiate. In this section, we will discuss differentiating trigonometric functions. Derivatives of all 6 trigonometric functions are given, and we show the derivation of the derivative of sine x and tan x. In this section, we derive the formulas for the derivatives of the exponential and logarithm functions. In this section, we give the derivatives of all 6 inverse trig functions, and we show the derivation of the formulas for inverse sine, inverse cosine, and inverse tangent. In this section, we define the hyperbolic functions, give the relationships between them, and some of the basic facts involving hyperbolic functions. We also provide the derivative of each of the 6 hyperbolic functions and show the derivation of the formula for hyperbolic sine. In this section, we will discuss implicit differentiation. Not every function can be explicitly written in terms of the independent variable, e.g. y is equal to f of x, and yet we still need to know what the differential of f of x is. Implicit differentiation will allow us to find derivative in these cases. Knowing implicit differentiation will allow us to use one of the more important applications of derivatives, related rates, which is in the next section. In this section, we will discuss the only application of derivatives in this section, which is related rates. In related rate problems, we are given the rate of change of one quantity in a problem and asked to determine the rate of one or more quantities in the problem. This is often one of the more difficult sessions for students, and we work on quite a few problems in this session, so hopefully by the end of this session, you get a decent understanding of how these problems work. In this session, we define the concept of higher order derivatives and give a quick application of the second order derivative and show how implicit differentiation works for higher order derivatives. In this session, we will discuss logarithmic differentiation. Logarithmic differentiation gives an alternative method for differentiating products and quotients, sometimes easier than using the product and quotient rule. More importantly, however, is the fact that logarithm differentiation allows us to differentiate functions that are in the form of one function raised to another function, that is, there are variables in both the base and exponents of the function. The derivative of a function f of x is defined as follows, and its notations include differential of f of x, dy dx, d dx of f of x, and capital letter dx of f of x. So here we have a question. Find derivative of f of x is equal to x cubed using the definition of the derivative. So let's solve this. Okay, so we start with the definition. Differentiation of f of x is equal to f of x plus h minus f of x divided by h as we limit h to 0. Substitute f of x equals to x cubed into f of x plus h, and you arrive at x plus h cubed. Expand f of x plus h, which is the same thing as x plus h times x plus h times x plus h. So when you open the brackets, you're going to end up with x cubed plus 3x squared h plus 3xh squared plus h cubed. Next, you substitute the value of f of x plus h and f of x equals to x cubed into the definition. And that will give you x cubed plus 3x squared h plus 3xh squared plus h cubed minus x cubed divided by h as you limit h as it tends to 0. Simplify the numerator. By subtracting x cubed from x cubed, and you are left with 3x squared h plus 3xh squared plus h cubed divided by h as you limit h to 0. Factor h from the numerator, and that will give you h times 3x squared plus 3xh plus h squared divided by h as you limit h to 0. Cancel h, and you're left with 3x squared plus 3xh plus h squared as you limit x to 0. Take the limit as h tends to 0. And what that simply means is anywhere you see h, you substitute with 0. And you are left with 3x squared plus 3x times 0 plus 0 squared. And we all know that 0 squared is 0 and 3x times 0 is 0. So this is going to leave us with 3x squared plus 0 plus 0. And that will give us 3x squared. And you arrive at your final answer. Next, we have a question. Use the definition of derivative to compute the differentiation of x for f of x is equals to 1 over x. So we start with the definition. Differentiation of f of x is equals to f of x plus h minus f of x divided by h as we limit h to 0. Now, we substitute f of x is equals to 1 over x into f of x plus h, and this will give you 1 divided by x plus h. So now we have our differentiation of f of x equal to 1 divided by x plus h minus 1 over x divided by h as we limit h to 0. Now, if we find the LCM, we will arrive at x times x plus h, and x plus h in x times x plus h will give you x times 1 will give you x, and x in x times x plus h will give you x plus h, and x plus h times minus 1 will give you minus x plus h. So you are left with x minus s plus h divided by x times s plus h divided by h. So when you open the bracket of the numerator, you have minus times x as minus x and minus times plus h as minus h, and that will be x minus h divided by x times x plus h divided by h. And we know that minus x and x will cancel out. So that will leave you with minus h divided by x plus h divided by h. You can factor out h so that you have h times minus 1 divided by x plus h divided by h. And if you look at this very well, divided by h is same thing as times 1 over h, so h can cancel out h. So when you simplify the fraction, you are left with minus 1 divided by x times x plus h as you limit h to 0. Now you take the limit of h as it tends to 0, and you are going to be left with minus 1 divided by x times x plus 0. And this will leave us with minus 1 divided by x times x, which is the same as minus 1 divided by x squared. And that's your final answer. So in this question, we're asked to compute the derivative of f of x is equals to s squared plus 3x using the definition. And as we already know, the formula for that is differential of f of x is equals to f of x plus h minus f of x divided by h as you limit h to 0. Now, we substitute f of x is equals to x squared plus 3x into f of x plus h. You will get x plus h squared plus 3x plus h. When we expand f of x plus h, s plus h will multiply s plus h, and that will give you s squared plus 2xh plus h squared. Then 3 will open the bracket, which is x plus h, and you're going to have plus 3x plus 3h. So in total, f of x plus h will give you s squared plus 2xh plus h squared plus 3x plus 3h. Now you substitute that value into the limit definition, and you have s squared plus 2xh plus h squared plus 3x plus 3h minus s squared plus 3x in brackets divided by h as you limit h to 0. Now, when you simplify the numerator, you have s squared plus 2xh plus h squared plus 3x plus 3h minus s squared minus 3x all divided by h as you limit h to 0. And when you cancel out terms, you're going to end up with 2xh plus h squared plus 3h divided by h as you limit h to 0. Now, you factor h from the numerator and you have h times 2x plus h plus 3 in brackets divided by h. And once h cancel out h, you have 2x plus h plus 3 as you limit h to 0. Now, once you take the limit of h to 0, h returns to 0, so you are left with 2x plus 0 plus 3, which is equals to 2x plus 3, and that's your final answer. So our next question We are asked to prove that the differentiation of f of x is equal to nx n minus 1 for f of x is equal to x raised by n using the definition. So we start with the definition, which is f of x plus h minus f of x divided by h as we limit h to 0. And once we substitute f of x is equals to x of n into that formula, we have f of x plus h is equals to x plus h raised to power n. Now, if we expand x plus h raised to power n using the binomial theorem, we get x plus h raised by n is equals to x raised by n plus nx n minus 1 times h plus n times n minus 1 divided by 2 times x raised by n minus 2 times h squared plus and so on up to plus h raised to power n. Now, when we substitute that into the limit, we have differential of f of x is equals to x raised by n plus n times x raised by n minus 1 times h plus n times n minus 1 divided by 2 times x raised by n minus 2 times h raised by 2 plus and so on up to plus h raised by n minus x raised by n divided by h as we limit h to 0. Now, once we simplify the numerator, we have the differential of f of x is equals to n times x raised by n minus 1 times h plus n times n minus 1 divided by 2 times x raised by n minus 2 times h squared plus and so on up to plus h raised by n divided by h as we limit h to 0. Now, once we factor out h, we have h times n times x raised by n minus 1 plus n times n minus 1 divided by 2 times x raised by n minus 2 times h plus and so on all to plus h raised by n minus 1 divided by h. As once h cancel out, we are left with n times x raised by n minus 1 plus n times n minus 1 divided by 2 times x raised by n minus 2 times h plus and so on up to plus h raised by n minus 1. Now, once you limit h to 0, 0 times n minus 1 divided by 2 times x raised by n minus 2 will give you 0, and 0 raised by n minus 1 will give you 0. So you are left with n times x raised by n minus 1, and that's the final answer. Under adaptation of the derivative, we are going to look at two key concepts. One, the derivative represents the rate of change of a function with respect to its independent variable. And two, it can be interpreted as the slope of the tangent line to the graph of a function at a point, the velocity of an object when the function represents position over time, and the instantaneous rate of change of a quantity. Now we are given a question to solve. Interpret the differentiation of f of x for f of x equals to x squared at x is equals to 3. So we start by computing the derivative of f of x equals to x squared. And when you differentiate that, you get 2x equals 2 times x raised to power 2 minus 1. And 2 minus 1 is 1. So that will leave you with 2x raised to power 1, which is the same thing as 2x. So next we evaluate the differentiation of f of x at x equals to 3. And that will give you 6, because when you slot in 3 in x, that will be 2 times 3, which will give you 6. So the interpretation is the slope of the tangent line to y equals to x squared at x equals to 3 is 6. If y is equals to x squared represents position over time, the instantaneous velocity at x equals to 3 is 6 units per unit time. So next we are going to look at a ball that is dropped from a height of h of t equals to 20 minus 5t squared, and we're asked to find a velocity at t equals to 2. So we compute the derivative of h of t. And when you differentiate 20, that will give you 0. And when you differentiate minus 5t squared, that will be 2 times 5, 10, and 2 minus 1, 1. And you are left with minus 10t. Now it's time to evaluate the differential of h of t at t equals to 2. All you have to do is slot in 2 everywhere you see t, and you get the differential of h of 2 is equal to minus 10 times 2, which is equal to minus 20. Now the interpretation. The velocity of the ball at t equals to 2 is minus 20 units per second. And the negative sign indicates the ball is moving downward. Now, in this question, the revenue generated by selling X units of a product is capital R of X equals to 100X minus 2X squared. Find and interpret the marginal revenue when X is equals to 20. Now, we start with computing the derivative of R of X, and that's d dx of 100x minus 2x squared. Now we know when you differentiate 100x, you're going to get 100. And when you differentiate 2x squared, that will be 2 times 2, 4, and 2 minus 1. You'll be left with 4x. So when you evaluate the differentiation of r of x at x equals to 20, all you have to do is slot in 20 everywhere you find x, and that will give you 100 minus 4 times 20. I know that 4 times 20 is 80. So 100 minus 80 will give you 20. Now for the interpretation. The marginal revenue at x is equals to 20 is 20. This means that producing and selling one additional unit when x equals to 20 will increase revenue by 20 naira. This is actually an example of differentiation applied to business or finance. We'll solve more of this type of question in the part 2, but I brought it here to show you an example of interpretation of differentiation. In this question, we're asked to find the equation of the tangent line to f of x is equals to square root of x at x equals to 4. So we compute the derivative of f of x is equals to square root of x, and don't forget we can write f of x as x raised to the power half. So once you have x raised to the power half, the differentiation of f of x is half times x, half minus 1, which is minus half. And that can also be rewritten as 1 divided by 2 square root of x. Now, if you evaluate the differentiation of f of x at x equals to 4, you have 1 over, all you have to do is put in 4 anywhere you see x, and you get 1 divided by 2 times square root of 4. I know that square root of 4 is 2, so that will be 1 divided by 2 times 2, which is equals to 1 over 4. This is the slope of the tangent line. Now, to find the point of tangency, put in 4 in the initial question. So that will be f of 4 equals to square root of 4, which is equals to 2. Now, the point is 4 and 2. Now, use this point slope form of the equation of a line, which is y minus y1 is equals to m times x minus x1. Substituting m is equals to 1 over 4, x1 is equals to 4, and y1 is equals to 2. So you get y minus 2 is equals to 1 divided by 4 times x minus 4. And when you simplify this by opening the bracket, you are going to end up with 1 over 4x minus 1 over 1, which is the same thing as 1. When you subtract minus 1 from plus 2, because when you carry 2 to the other side, it becomes plus 2, you end up with y is equals to 1 over 4x plus 1. So the equation of the tangent line is y equals to 1 over 4x plus 1. So let's go over some basic derivatives, rules, and formulas. So first off, we have the power rule, and that is whenever you have f of x is equals to x raised to power n, differentiation of f of x will give you n times x raised to power n minus 1, where n belongs to all real numbers. Now, For constant rule, when you have f of x is equals to c, when you differentiate x, you get 0, where c is a constant. For the sum/difference rule, when you have f of x is equals to g of x plus or minus h of x, the differentiation of x will give you the differentiation of g of x plus or minus the differentiation of h of x. Now, for trigonometric derivatives, when f of x is equal to sine x, the differentiation of f of x will give you cos x. When f of x is equal to cos x, the differentiation of f of x will give you minus sine x. When f of x is equal to tan x, the differentiation of f of x will give you sec square x. And when f of x is equal to cosec x, the differentiation of f of x will give you minus cosec x cot x. Now, when you have f of x is equal to sec x, the differentiation of f of x will give you sec x tan x. And when you have f of x is equal to cot x, the differentiation of f of x will give you minus cosec square x. Now, for exponential and logarithmic derivatives, when f of x is equal to exponent raised to power x, the differentiation of f of x will give you exponent raised to power x. Now, when you differentiate a raised to power x, differentiation of f of x will give you a raised to power x ln a, where a is greater than 0 and a is not equal to 1. And when you have f of x is equal to ln x, differentiation of f of x will give you 1 over x, where x is greater than 0. And when you have f of x log to base a of x, the differentiation of f of x will give you 1 over x ln a, where x is greater than 0, a is greater than 0, and a is not equal to 1. Now we will move on to inverse trigonometric derivatives. When f of x is equal to arc sine x, the differentiation of f of x is equal to 1 divided by the square root of 1 minus x squared, where the absolute value of x is less than 1. And when f of x is equal to arc cos x, differentiation of f of x will give you minus 1 divided by the square root of 1 minus x squared, where the absolute value of x is less than 1. Now, when f of x is equal to arc tan x, the differentiation of f of x will give you 1 divided by 1 plus x squared, where x belongs to all set of real numbers. Now, when you have f of x is equal to arc cot x, the differentiation of f of x will give you minus 1 divided by 1 plus x squared, where x belongs to all set of real numbers. And when you have f of x is equal to arc sec x, the differentiation of f of x is equal to 1 divided by the absolute value of x multiplied by the square root of x squared minus 1, where the absolute value of x is greater than 1. And when you have f of x is equal to arc cosec x, the differentiation of f of x is equal to minus 1 divided by the absolute value of x multiplied by the square root of x squared minus 1, where the absolute value of x is greater than 1. Now, for hyperbolic function derivatives, when you have f of x is equal to sine hx, Differentiation of f of x will give you cos hx. Now when you have f of x is equal to cos hx, differentiation of f of x will give you sin hx. And when you have f of x is equal to tan hx, differentiation of f of x will give you sec h squared x. And when you have f of x is equal to cot hx, differentiation of f of x will give you minus cosec h squared x. And when you have f of x is equal to sec hx, differentiation of f of x will give you minus sec hx tan hx. And when you have f of x is equal to cosec hx, differentiation of f of x will give you minus cosec hx cot hx. Now for chain rule, if you have f of x is equal to g of h of x, if you differentiate f of x, you get the differentiation of g of h of x times differentiation of h of x. For product rule, d dx of f of x times g of x will give you differentiation of f of x times g of x plus f of x times differentiation of g of x. Now for quotient rule, d dx of f of x divided by g of x will give you the differentiation of f of x times g of x minus f of x times differentiation of g of x divided by g of x squared, where g of x is not equal to 0. In this section, we will apply standard differentiation formulas like power rule, sum and difference rule, constant rule, and constant multiple rule. So here are some key concepts that we need to take cognizance of. So for the power rule, when you differentiate x of n, the n will come down and multiply the x, and you subtract 1 from the power, which is n minus 1. Now for the sum or difference rule, when you differentiate f of x plus or minus g of x, you get the differentiation of f of x plus or minus the differentiation of g of x. And as for constant rule, differentiation of any constant is equal to 0. Now for constant multiple rule, when you differentiate constant c times f of x, you get the constant times the differentiation of f of x. In this question, we are asked to differentiate f of x is equal to 5 cubed minus 4x squared plus 3x minus 7. So using the power rule for each term, when you differentiate 5x cubed, we are going to have 3 times 5, 15, and 3 minus 1, 2. So that's 15x squared. Now, d dx of 4x squared will give you 2 times 4, 8, and 2 minus 1, 1. So that's 8x. Now, d dx of 3x will be 3, and d dx of minus 7 will be equal to 0. So when you combine the results, you are going to get 15x squared minus 8x plus 3. So in this question, we're asked to find derivative of f of x is equal to 3 divided by x squared plus 4x raised to the power minus 3. You will notice that we can actually rewrite the terms with negative exponents. For example, 3 divided by x squared can be written as 3 times x raised to the power minus 2. So now you have f of x is equal to 3x raised to the power minus 2 plus 4x raised to the power minus 3. Now once you apply the power rule, d dx of 3x raised to the power minus 2 will give you minus 2 times 3, which is minus 6x, and minus 2 minus 1, which is minus 3. So that's minus 6x raised to the power minus 3. Now d dx of 4x raised to the power minus 3 will be minus 3 times 4, which is minus 12x, and minus 3 minus 1, which is minus 4. So when you combine the result, the differentiation of f of x will give you minus 6x raised to the power minus 3 minus 12x raised to the power minus 4. And it can also be rewritten as differentiation of f of x is equal to minus 6 divided by x cubed minus 12 divided by x raised to the power 4. So in this question, we're asked to differentiate f of x is equal to 7 times x raised to the power 4 minus 2 times square root of x plus 5 divided by x. So first, we rewrite the terms for easier differentiation. F of x is equal to 7x raised to the power 4 minus 2 times x raised to the power half plus 5 times x raised to the power minus 1. Now, if we apply the power rule to each term, d dx of 7x raised to the power 4 will give you 4 times 7, which is 28, and 4 minus 1, which is 3. So that will give you 28x raised to the power 3. Now, d dx of minus 2x raised to the power 1 over 2, 1 over 2 times 2 we cancel out, and half minus 1 will give you minus half. So that's minus x raised to the power minus half. Now, d dx of 5x raised to the power minus 1. Minus 1 multiply 5 and it become minus 5. And minus 1 will give you minus 2. So that will give you minus 5x raised to the power minus 2. Now, when you combine the results, you get the differentiation of f of x will give you 28x cubed minus x raised to the power minus half minus 5x minus 2. And that can be rewritten as 28x cubed minus 1 divided by the square root of x minus 5 divided by x squared. In this question, we are told to differentiate g of x is equal to 2x cubed minus 4x squared plus 3 in bracket multiplied by x plus 1 using the distributive property. So first, we expand the products. When you multiply 2x cubed minus 4x squared plus 3 times x plus 1, you get 2x raised to the power 4 minus 4x cubed plus 3x plus 2x cubed minus 4x squared plus 3. When you combine like terms, you get 2x4 minus 2x3 minus 4x2 plus 3x plus 3. Note, minus 4x3 plus 2x3, that's how we got our minus 2x3. Now, differentiate term by term. Differentiation of g of x will give you d dx of 2x4 minus d dx of 2x3 minus d dx of 4x squared plus d dx of 3x plus d dx of 3. So when you differentiate 2x raised to the power 4, that will be 2 times 4, which is 8, and 4 minus 3, which is 3. 4 minus 1, which is 3. So that will give you 8x raised to the power 3. Now, when you differentiate minus 2x3, that will be 2 times 3, 6, 3 minus 1, 2. So that will be minus 6x squared. Now, when you differentiate 4x squared, you have 2 times 4, 8, and 2 minus 1, 1. That's 8x. And when you differentiate 3x, that will be 3. And when you differentiate 3, that will be 0. And your final answer will be the differentiation of g of x is equal to 8x raised to the power 3 minus 6x squared minus 8x plus 3. So for product rule, if f of x and g of x are differentiable functions, the product rule states that d dx of f of x times gx is equals to differentiation of f of x times g of x plus f of x times differentiation of g of x. Under the quotient rule, if f of x and g of x are differentiable functions and g of x is not equal to 0, the quotient rule states that d dx of f of x divided by g of x is equals to differentiation of f of x times g of x minus f of x times differentiation of g of x divided by g of x squared. So in this question, we're asked to differentiate f of x is equal to x squared plus 1 multiplied by x minus 3. So first of all, we're going to let u of x equals x squared plus 1 and let v of x equals x minus 3. And we need to compute our u of x differentiated and v of x differentiated. So when you differentiate u of x, you get 2x, and when you differentiate v of x, you get 1. Because when you differentiate x squared plus 1, 2 times x will give you 2x, 2 minus 1 will give you 1, plus 1 will give you 0, differentiate x, that's 1, differentiate minus 3, that's 0. So when you apply product rule, which is u of x differentiated times v of x plus u of x times v of x differentiated, and substitute the value of u of x, u of x differentiated, v of x, and v of x differentiated that we got earlier, you are going to end up with 2x times x minus 3 plus x squared plus 1 times 1. And when you expand and simplify, you get 2x squared minus 6x plus x squared plus 1. And when you combine like terms, your final answer will be 3x squared minus 6x plus 1. Question, we are asked to differentiate f of x is equals to x squared times sine x. So let our u of x equals to x squared and our v of x equals to sine x. So once you compute u of x differentiated and v of x differentiated, you end up with u of x differentiated equals to 2x and v of x differentiated equals to cos x. Now, once we apply product rule and we substitute the value of u of x differentiated, v of x, and v of x differentiated, we have 2x times sine x plus x squared times cos x. Now, once you simplify that, you have 2x sine x plus x squared times cos x as our final answer. So now, for this question, we are asked to differentiate g of x is equals to x squared divided by x plus 1. So, since it's a division question, we are going to use quotient rule. So let u of x equals to x squared and v of x equals to x plus 1. We need to compute the differentiation of u of x and v of x. So when you differentiate u of x, you get 2x, and when you differentiate v of x, you get 1. Now, once we apply quotient rule and we substitute the value of u of x and differentiated u of x, v of x, and v of x differentiated, you are going to end up with 2x times x plus 1 minus x squared times 1 divided by x plus 1 squared. So now, once you expand and simplify the numerator, you are going to end up with 2x squared plus 2x minus x squared divided by x plus 1 squared. Now, if you look very well, you see that 2x squared can subtract x squared, and that will give you x squared plus 2x divided by x plus 1 squared. And you can factor x out and end up with x times x plus 2 divided by x plus 1 squared as your final answer. So in this question, we're asked to differentiate g of x is equals to sine x divided by x squared. So let u of x equals sine x and v of x equals to x squared. So we need to compute the differentiation of u of x and differentiation of v of x. So when you differentiate u of x, you get cos x, and when you differentiate v of x, you get 2x. Now we apply the quotient rule and we substitute the value of u of x differentiated, v of x, and v of x differentiated, and we'll arrive at cos x times x squared minus sine x times 2x divided by x squared squared. Now, once we simplify the numerator and denominator, we arrive at x squared times cos x minus 2x times sine x divided by x raised to the power 4. Now, we can simplify further by dividing each term in the numerator by x raised to the power 4. And once we do that, x squared will cancel 2, and that will give us cos x divided by x squared. And x will cancel 1x, and that will be minus 2 sine x divided by x raised to the power 3. And our final answer will be cos x divided by x squared minus 2 sine x divided by x cubed. Now, moving on to derivatives of trigonometric functions. Here we are asked to differentiate f of x is equal to sine x plus cos x. And all we have to do is differentiate each term using the basic derivatives of sine and cosine. So when you find d dx of sine x, you get cos x, and when you find d dx of cos x, you get minus sine x. So your final answer is cos x minus sine x. Next, we are asked to differentiate g of x is equal to tan x minus cot x. Now, once we use the derivatives of tangent and cotangent, we arrive at d dx of tan x minus d dx of cot x. And tan x differentiated will give you sec square x, and cot x differentiated will give you minus cosec square x. So when you multiply minus cosec square x times minus, you get plus cosec square x. So your final answer is sec square x plus cosec square x. So in this question, we're asked to find the differentiation of h of x equals to x sine x. So this is a product of two functions, so we apply the product rule. So let u of x equals x and let v of x equals sine x. Now, differentiation of h of x will give you u of x differentiated times v of x plus u of x times v of x differentiated. Now, when you differentiate u of x and v of x, differentiation of u of x will give you 1 and differentiation of v of x will give you cos x. So once you substitute all the values of u of x differentiated, v of x and v of x differentiated, you end up with 1 times sine x plus x times cos x. And your final answer will be sine x plus x cos x. Now, for this question, we are told to differentiate q of x is equal to sec x divided by tan x. This is a quotient of two functions, so we apply the quotient rule. So let u of x equals to sec x and v of x equals to tan x. When you differentiate q of x, you get u of x differentiated times v of x minus u of x times v of x differentiated divided by v of x squared. So when you differentiate u of x, you get sec x tan x, and when you differentiate v of x, you get sec square x. So once you substitute all the value you got into the quotient formula, you arrive at sec x times tan x minus sec x times sec square x divided by tan x squared. So once you simplify the numerator, you arrive at sec x tan square x minus sec cube x divided by tan square x. Now, you can actually factor out sec x, and once you do that, you arrive at sec x times tan square x minus sec square x in brackets divided by tan square x, and that's your final answer. So let's go over the basic rules of derivatives of exponential and logarithmic functions. So d dx of exponent of x will give you exponent of x, d dx of a of x will give you a of x ln a, d dx of ln x will give you 1 over x, and d dx of log x to base a will give you 1 divided by x ln a. So for this question, we're asked to differentiate f of x is equals to exponent of x plus 3 ln x. So what we have to do is differentiate each term separately using the derivative rules. So when you differentiate exponent of x, you're going to end up with exponent of x. And when you differentiate 3 ln x, you can bring out the constant 3 and find d dx of ln x, and d dx of ln x will give you 1 over x. So that will give you 3 times 1 over x. So your final answer is exponent raised to power x plus 3 divided by x. So for this question, we are asked to differentiate g of x is equals to x squared times exponent raised to power x. Now this is the product of two functions, so we can apply the product rule. Let u of x equals x squared and let v of x equals exponent raised to power x. Now, the product rule formula we're going to use is u differentiated times v of x plus u of x times v of x differentiated. Now, when you differentiate u of x and v of x, u of x differentiated will give you 2x, and v differentiated will give you exponent raised to power x. And when you substitute those values into your product rule formula, you end up with 2x times exponent raised to power x plus x squared times exponent raised to power x. And once you factor out exponent raised to power x, you are left with exponent raised to power x times 2x plus x squared. For this question, we're asked to differentiate h of x is equal to ln x cubed. So all we have to do is to simplify h of x using logarithmic properties. We know that based on rule of log, the 3 will come down to the back, and that will be 3 ln x. So once we have it in that form, once we differentiate h of x, we bring out 3 since it's a constant, and ln x will become 1 over x. So our final answer will be 3 divided by x. So now, we are asked to differentiate k of x is equal to ln x divided by x. This is a quotient, so let's apply quotient rule. let u of x equals ln x and let v of x equals x. And we know from quotient rule that the formula is u differentiated of x times v of x minus ux times vx differentiated divided by vx squared. So once we differentiate ux and vx, we get our ux differentiated as 1 divided by x and our vx differentiated as 1. So once we substitute the value into the quotient rule formula, we have 1 divided by x times x minus ln x times 1 divided by x squared. So once we simplify it, we get 1 minus ln x divided by x squared as our final answer. So the chain rule is a fundamental differentiation technique used when one function is composed of another. That is, if f of x is equal to g of h of x, the rule states that d dx of g of h of x is equal to g differentiated of h of x times h of x differentiated. So in this question, we're asked to differentiate f of x is equal to 3x squared plus 2 raised to power 5. Now, let u equals 3x squared plus 2 so that f of x equals u raised to power 5. Now, we differentiate u raised to power 5 with respect to u, and we all know that d du of u of 5 will give you 5 times u and 5 minus 1, so that will give you 5u raised to power 4. Now, when you differentiate u equals to 3x squared plus 2, you're going to end up with 6x, because 2 times 3x will give you 6x, and differentiation of 2 will be 0. So, once you apply chain rule, differentiation of f of x will give you 5u raised to power 4 times du dx. All you have to do now is substitute u is equals to 3x squared plus 2, and du dx is equals to 6x. And you arrive at 5 times 3x squared plus 2 raised to power 4 times 6x. Once you simplify this, you get 30x times 3x squared plus 2 raised to power 4. In this question, we are told to differentiate g of x is equal to cos x cubed. So let our u equals x cubed, so that g of x equals cos u. Now we differentiate cos u with respect to u, and that will be d du of cos u, and that will give you minus sine u. Now when you differentiate u is equal to x cubed, you are going to get du dx is equal to 3x squared. Now when you apply chain rule, you are going to get minus sine u times du dx. So once you substitute u is equal to x3 and du dx is equal to 3x squared, you are going to get minus sine x cubed times 3x squared. And your final answer is minus 3x squared sine x cubed. So for this question, I asked to differentiate h of x is equal to e raised to power sine x. So let our u equal sine x, so that h of x will equals e raised to power u. Now, differentiate e raised to power u with respect to u, and you're going to have d du of e raised to power u is equals to e raised to power u, where e is exponent. Now, differentiate u equals to sine x, and you get du dx is equals to cos x. Now, when you differentiate h of x, you will get exponent raised to power u times du dx. All you have to do now is substitute u is equal to sine x and du dx is equal to cos x, and you are going to get e raised to power sine x times cos x as your final answer. So for this question, we have differentiate k of x is equal to ln 1 plus x squared. So let u equals 1 plus x squared, so that k of x will equals ln u. Now, differentiate ln u with respect to u, and you get d du of ln u equals to 1 over u. Now, differentiate u is equal to 1 plus x squared, and you are going to have du dx equals to 2x. Now, apply the chain rule, and you have 1 over u times du dx. All you have to do now is substitute u is equal to 1 plus x squared, and du dx equals to 2x, and you're going to arrive at 1 divided by 1 plus x squared times 2x. And once you simplify this, you're going to get 2x divided by 1 plus x squared as your final answer. So now the question says to differentiate f of x is equals to arc sine x squared. So once you apply chain rule, since f of x is equals to arc sine u, where u is equals to x squared, differentiation of f of x will give you 1 divided by square root of 1 minus u squared times du dx. Now, substitute u is equals to x squared and du dx is equals to 2x, and you arrive at 1 divided by the square root of 1 minus x squared times 2x. And once you simplify that, you get 2x divided by square root of 1 minus x raised to the power 4. So in this question, we are to differentiate g of x is equals to arctan square root of x. And we are going to use chain rule to do that. So let u equal square root of x such that g of x differentiated will give you 1 divided by 1 plus u squared times du over dx. Now, since u is equal to square root of x can be rewritten as x raised to the power half, then du dx is equal to half times x raised to the power minus half. And that can also be written as half times 1 divided by x raised to the power half, which is also half times 1 over square root of x. And that will give you 1 over 2 times square root of x. Once you substitute the value of u is equals to square root of x and du dx is equals to 1 over 2 times square root of x into the equation. Now, g of x differentiated is equals to 1 divided by 1 plus u squared times du dx can be rewritten as 1 divided by 1 plus, in brackets, square root of x squared times 1 divided by 2 square root of x. And this can be further simplified to get 1 divided by 1 plus x times 1 over 2 times square root of x, which can also be written as 1 divided by 2 times square root of x times 1 plus x in bracket. So now let's look at some questions under derivatives of hyperbolic functions. So in this question, we are asked to differentiate f of x is equal to sine h of x plus 3 cos h of x. So we differentiate each term separately. d dx of sine h of x plus 3 times d dx of cos h of x. So when you differentiate sine h of x, you get cos h of x. And when you differentiate 3 d dx of cos h of x, you get 3 sine h of x. So your final answer will be cos h of x plus 3 sine h of x. So in this question, we're asked to differentiate g of x is equal to tan h of x squared. So let us apply chain rule. Let g of x equals tan h of u, where u is equal to x squared. So differentiation of g of x will give you d du of tan h of u times du dx. So when we differentiate tan hu, that will be d du of tan hu equals to sec h squared u. Now, let us differentiate u is equal to x squared. That will give you du dx is equal to 2x. So when we substitute tan hu is equal to sec h squared u and du dx is equal to 2x into the chain rule equation, we end up with differentiation of g of x is equal to sec h squared x squared times 2x, which can also be written as 2x times sec h squared x squared. We've just scratched the surface of differentiation. In part 2, we'll delve deeper into more complex topics, including implicit differentiation, logarithmic differentiation, related rates, higher differentials, and application of differentiation to business and finance. Remember, practice is key. Keep exploring and applying this concept to various functions. Happy differentiating. Thank you for watching. Please don't forget to like, share, comment, and subscribe. Bye.